Vehicles to teach STEM subjects: science, technology, engineering, mathematics.
What department is this done in?
This is considered industrial design. Yeah. So this would be like an engineering technology kind of class. The prevalence of these devices is just going to be huge. That's going to really affect job growth and job creation if you have this kind of experience, know how to design and implement autonomous systems. This is funded by the Department of Education. This is a DOE grant.
Federal.
Federal, that's right, yeah. At their most sort of boiled down essence, a multi-rotor, or it's sometimes called UAVs, unmanned autonomous vehicle, and anything that is an unmanned autonomous vehicle is composed of many different subsystems. So sometimes they're also referred to as UAS, which is unmanned autonomous systems. They're really, in effect, very simple machines with a lot of complex software operating them. So in the example of this quad rotor, it's called a quad rotor or a quadcopter because it has 4 motors. You guys can all see. But if I was to try and fly this myself, in other words, manually, it would be quite hard to manage 4 different throttle controls for 4 different motors, right? So effectively, what we introduced into the system. Now, let me back up a second. If this were an airplane, a model airplane, we'd have 1 propeller, 1 motor, 1 throttle. That's pretty simple. But this is kind of a hybridized vehicle in that it sort of mimics the roll and pitch and yaw of an airplane, but flies more like a helicopter. Because if all 4 of these motors were to spin up right now, which aside from being a little dangerous so close to my face, but you have a thrust vector, right? You have thrust coming from these 4 propellers, lifting it straight up. Well, if it was an airplane, it would probably have a propeller in the front or something pushing in the back, and actual lift bodies like wings and stabilizers and things like that. But this doesn't have that. This is effectively, unless the motors are spinning, this is a flying brick. Right? It has no lifting capability. It has no aerodynamic surfaces. The only aerodynamic surface is the actual propeller. Watering, irrigation, to ripening, to infection or disease can be really quickly picked up by the air from a vehicle like this. Now we're using this one here at the school in particular to document the construction that's going on right now. What we've done with this, and I'll show you also that this is this has a front-facing camera here, but it's got this is called a gimbal, and it's on 2 axes. This one over here actually has it on 3 axes, meaning that it'll pan as well. So this has roll and pitch. But what we've done here, you'll see there's another circuit board here. This board and this camera have an inertial motion unit or an inertial sensing. So if I set a level, no matter how I fly this, this is gonna hold the horizon and hold its pitch.
That's in addition to the inertial sensors?
Right, this is a separate system. We're sort of really in our infancy with the technology. The product we're using here is an open source software product. And if you guys are at all unfamiliar with open source means that Olaf in Sweden and Hitan here at PCC can develop code for the project, contribute it to the project to improve the project. Nobody's getting paid for it. So now we're connected. I'm able to control this, but so take a look at your gimbal camera. Is that, see? So that's a stabilized camera. What it does is it locks in on the horizon. This has a very slow follow. So when I'm yawing, yaw is this axis, the rudder. When I'm yawing, this kind of follows slowly. Because think of it, if this were an airplane, if I wanted to make a 90-degree turn, I can't just turn on the center of my aircraft. Say my hand is the aircraft. I'm flying, right? If I want to turn, I've got to bank and turn. With this, I can just yaw right on the center because of the nature of how the aircraft is designed. So what you see here is there's this sliding rail, which enables me to fiddle with the center of gravity, which is also quite important. So I can slide, let me see if I can do this without dropping. So I can slide this back and forth to accommodate for a heavier battery, for a different camera, and that sort of thing. And if you look through that center bowl, you see a little bit of orange. That's the flight controller board, but that's a commercial product. Whereas the open source, which is really what we use here, affords us the ability to control just about any parameter. So the other thing, whenever I put on a new battery, I want to make sure the center of gravity is good. This is the center point where my thumbs are, so I've got a little pitch down. So I'm just going to move this back ever so slightly. Trimming it, yeah. Yeah, yeah. That's pretty good. Let's get our battery sensor hooked up. So I've got my GoPro here, but then you see that I have another camera here. This little camera is called the first person view camera. And I can use this I use this video feed, and that's transmitted from this video antenna, video transmitter, to my ground station. That's my receiving end. And then I would set up I have a feed here that comes into this monitor from this ground station via this transmitter, and then I can see where I am flying if I want to frame up a shot. Yeah, I mean, it's like you're in the cockpit. It's actually much easier to fly with from a first-person view than it is to fly watching it in the sky, because you kind of run into issues of orientation. Once this gets a few hundred feet away from you, you're like, is that the front? Is that the back? I'm not sure. So this really aids you in like, hey, where am I? So let me get my laptop set up here. This is where we are right now. This is the VCC campus, and we get this data comes in via the internet right now, and it's coming in through Google satellite maps. Now, if I click on this drop down, these are all different satellites that I can pick up and get a different view or different information. If I wanted to fly around this field, I can just point and click. I'm setting waypoints right now.
Is this a real-time view?
Well, it's of the satellite. No, this is a stored picture, right? Because, and the way I know that, well, there's no construction here, but there's not only that, but there's a student center that was built here. So this is a pretty old image. So what this shows me is all the waypoints I created, and then the latitude and longitude of each waypoint, and the altitude. We're loading this route to this board, and the board can only have one route at a time. So, but you can store an infinite amount of routes, as you go. And then just to be sure that we have the mission that we want, I'm going to clear this mission out one more time, and I'm going to say read waypoints. And the read waypoints, now I'm pulling the waypoints off the board, confirming that I've got the proper mission needed. If we examine the actual script of the flight, I've added a bunch of things. I've added a takeoff command, and in between every waypoint I've added it's called do set ROI, so it knows to look at that point. And then at the bottom, the last two commands, which are pretty important too, return to launch, which is go back to where you started from, and then land. So it takes itself off and lands itself after running the mission. You're going to actually see, this is the representation of the quad itself. This is the symbol. You can actually see it moving. Look at the little spin up here.
There's no noise at all. That's bad.
Woohoo!
For anybody who's piloting in this situation is to always have eyes on it. I'm not flying it, but I'm using my finger on the throttle at mid-stick in case I need to take it over. So it stops here, it really locks into the jets, the air hits the land, and then continues to slowly come down. Wow. Hey! So you see So here's our flight.
Resolution is quite good.
Yeah, so this is 1080p at 60 frames per second, so a little bit more hyper real. Yeah, and that's what a stabilized camera does for you. That's what makes it feel so smooth. This is going to be a medical arts building for nursing and dental hygiene and stuff like that.
Has it ever been used to note problems in the construction?
That I don't know, but that's one of the reasons why the administration is really keen on us doing this. And then we also have, and you'll see it as we fly by it, the stationary time-lapse camera that we have set up as well.
So what do they expect to do with these particular sets of pictures?
Well, this is just a STEM project that the students and I are working on to make at the end of the construction, say, like, I'm sure there'll be like a gala for the opening, and that this would be a video that we would edit down and show as a moving time lapse. So this whole loop would start at the beginning and end at the finish of the construction in one cycle around.
Yeah, but you said that the administration
was
really
using
interested.
it for percentage completion for their contract with the contractor to say, you know, we see that you poured on this date, you did this and this, you know. For them, it shows them a percentage of completion. It keeps them on track. Okay, so we're coming in for a landing here. There you go.
Smooth landing.
Yeah, it does great.
Yeah, fly it over the group and we'll take a picture. Fantastic.